All right, so first page is just a lot of reading. So now we're going to go with what we learned the other day and go from there. So we're still going to check conditions, random. We're still going to see whether it says relatively normal. Okay, so we check to see if it's approximately normal. If it does not say it is normal, we got to check that it's greater than. Please add this. It should be greater than or equal to 30. Not that that's going to matter. Maybe. Well, maybe it will. It's greater than or equal to 30. So 30 counts. Just FYI. And then we go on from what we were doing. So the other day we learned about the new confidence interval formula. We're using this new letter. Love this board. Using this new letter, T. Okay, so we're using the new chart with T on it. Remember, this is the standard deviation of the sample. Okay. Square root of n, and remember, this is the mean. Okay, the average. So we're going to be putting all that together, which we did do the other day. Okay, but now we're going to do the whole problem start to finish. This is just talking about the properties of t-distribution. The only difference, even though it is normal, the one thing that's different is it's a little bit heavier in the tails. So there's a little bit more data on the tails in each side. Okay, it's still going to have the normal shape, but it's going to be a little bit heavier in the tails. So let's get into working some problems. All right, it says, suppose that a machine is designed to produce bolts that have a diameter of 5 millimeters. Every hour, a random sample, there's some of our information, 15 bolts is selected, and a 95% confidence interval for the mean diameter is constructed. If there is evidence that the mean is not 5, the machine has to be adjusted. In one particular sample, the mean diameter was 5.08, with a standard deviation of 0.11. Okay? So, let's do what we did already. Step 1, define the parameter. Now, this is going back to what we did in previous unit. We're going to actually define what it is. So, we're going to start off with true mean. And then we just write what we see. That's supposed to be an N, not a B. True mean. Okay? Of the diameter, well, let's just say bolt diameter. Make it easy. A bolt diameter. That's what we're talking about. So again, you just write true mean, and then just look at the paragraph and see what it's talking about. It's talking about the diameter of bolts, or bolt diameter. That's it. Number 2, check conditions. Random. Question mark. Well, we said it was random, so check mark, given. We're good to go. Now, there was a typo in this problem. Normal. Does it say it is normally distributed? No. Is our number bigger than 30? Nope. So, this is one of those ones that people have asked before. It's not greater than 30, so we proceed with caution. This happens. We still do our calculations, but we have to know that there's more chance for being wrong. So we proceed with caution. We have like a warning out there. FYI, it does not meet our requirement of numbers, so just take the data with a grain of salt. When I say it was a typo, there was supposed to be a sentence in there saying it was normally distributed. So we'll just keep going. Number 3, we're going to do the math. Now we're looking for a 95% confidence interval. Okay, so now we just do the math. We go back to our formula, which is all over the place. It's our mean, 5.08. We got that from the paragraph where it said the mean diameter is 5.08. We do plus or minus. I'm going to skip that space. Our standard deviation was 0.11, and the number of volts sampled was 15. Now this number here, the t-score, we go to our chart, which is why we need our blue chart out, our table, okay? And we go to the table. Now remember, we're going to look for degrees of freedom. So the degrees of freedom is n minus 1. So 15 minus 1 is 14. So we look at our chart. We go down the left side to 14. And we go over to a 95% confidence interval, which is at the bottom. Okay? So we get 95% confidence interval. We go up to degree of freedom of 14, and we find 2.145. And we write that right in here. That's our t-score. Okay? Make sure, pause if you have to, make sure that you see on your chart degrees of freedom 14 intersecting with 95% confidence interval. You gotta make sure you know how to use this chart. That's the one thing looking at the answer key, the review won't help you. You've gotta know how to use the chart. Alright. Now, we just do the math. 5.08 plus or minus. If I crunch these numbers, okay, take your calculator. The easiest way to probably do it is 0.11 divided by square root 14. Get that number. Then multiply that by 2.145. And you get that big long number. We're going to round it to 0.06. No, it's square root of 14 because remember, degrees of freedom is n minus 1. Oh, you're right. It is 14. I said 14, but I wrote 15. Thank you. Okay, so it is 14. It's this number right here, and I couldn't make it from here to there correctly. Thank you for that. So it is square root of 14. I think that's what I typed on the calculator. I did. So it's 0.06. This is why we always check our work, because human error. So now we're going to subtract 0.06 and add 0.06. So think about it, $5.08. If I subtract 6 cents, that's going to be $5.02. If I add 6 cents, that's going to be $5.14. That's my interval. And then number 4, we're going to have a sentence, but it's not going to be the longest sentence we've ever written. Here's what we write. We are 95% confident the interval, and we just write those numbers, from 5.02 to 5.14 captures the true mean, and we just copy that sentence. Of bolt diameter. That's it. So the sentence is going to be that very basic sentence. We are blank confident that the interval from blank to blank captures the true mean of fill in the blank with whatever sentence we put at the very beginning. Diameter. I don't know which word you're pointing at. Okay, similar idea. Suppose the administration of RISHS would like to estimate the average number of hours students spend doing homework. So that's going to be our what we're researching. In a random sample, that's important. 50 students. The average number was 6.3. Remember, that's mean. Okay? With an SD of 5.2. We want a 99% confidence interval. Okay? So number 1. What is our funky U? It's the true mean of hours Rockwood Summit High School students spend doing homework daily. on homework daily. Shorten it a couple words. Okay? So U is the true mean of hours Rockwood Summit High School students spend on homework daily. That's it. Number 2. Random, question mark, yes, given. They told us it was random. We underlined it. Is it approximately normal? Question mark. Yes, because 50 is greater than or equal to 30. And 50 was the number of students taken into consideration. Number 3, let's do the math. We're doing a 99% confidence interval. Our mean, our average was 6.3. Let's try to make that look like a 3. There we go. Plus or minus, we'll leave some space. Our standard deviation was 5.2 with a square root of, whoopsie, 49. Oh wait, my bad. I was right earlier. So this is supposed to be 50. That's what we type in there. So this was supposed to be 15 up here. You do the square root. You don't put the degrees of freedom in here. This was supposed to be 15. Okay? You do the square root of the number here, not the degrees of freedom. Degrees of freedom is just what we use on the chart. So this should be 50. It should have been 15. And if I type 14 on the calculator, I don't think I did, but if I did, it still ends up being 0.06. Okay, so we look at our chart. Now, degrees of freedom is n minus 1. So that's 49. But remember, if you look at your chart, there is no 49 on there. So we go back, we write it down to 40. That's what we look on. So we look on our chart, 99% confidence interval, go up until we hit the intersection of 40, and we'll get the decimal 2.704. So we take our calculator, we take 5.2, turn it on, 5.2, 0.2, there we go, divided by the square root of 50. Enter. We're going to multiply that by 2.704, which we got off the chart. And that gives us 1.988, so that's 1.99. So our range is 6.3 plus or minus 1.99. So 6 hours and 30 cents plus or minus $1.99.
7 points.
So if we subtract, we get 4.31 up to 8.29. And now we just have to write our sentence. Yep, we are 99% confident. The interval from 4.31 to 8.29 captures the true meaning of hours Rockwood Summit High School students spend daily on homework.